Hey guys and girls, in today's video I'm going to be showing you how to make a minimap. So we can see as player 2 walks around, the minimap updates, and if I move onto this green part, we can see that the minimap indicates that the player 2 is on the green part for both players. I am able to zoom in and zoom out. You may be thinking that all we're doing is updating the camera of the viewport frame as we walk around, but that is not what we're doing. If I select the frame and set clip descendants to false, we can actually see that the viewport frame is a lot larger than what we can see when the frame has clip descendants set to true. And as I walk around, we're not updating the camera, but we're shifting the viewport frame's position. So if we look at the position, we can see it's currently at 0.725, and as I walk around, the position updates. And once I get to the edge, it will update the viewport frame and wrap it round. So you can see once I get here, it updated the viewport frame and wrapped it round, and I can keep generating the viewport frame by walking over this edge. The first thing I'm going to do is create a base plate project, and I've created a few parts and I have anchored these parts just so that we can see where we are on the minimap. In order to restrict what gets added to the minimap, I'm going to make a new folder, and I'm going to call this folder map, and I'm going to move everything that I want to be added to the minimap into the map folder. Now let's create the minimap's GUI. So inside of starter GUI, I'm going to create a screen GUI and then a frame. We can design this frame to be any way we like, and we can have any position or size we like. So I'm just going to have a value of 16 for the position, and 300 and 300 for the size. Now let's create our viewport frame. So viewport frame, and this frame is important and it must have a few properties for our script to work correctly. The first thing I'm going to change is the light color to 000 and the light direction to 0, -1, 0, and I'm going to change the ambient to 255, 255, 255, which should be the max. And I am then going to change the anchor point to 0.5, 0.5, and I'm going to change the position, which is not that important, but I like to change it, to 0.5, 0.5, and the size needs to be set to 2, which is double the size of our frame. So now we can see that the viewport is double the size of the frame, and so that we can't see the edges inside of the frame, I'm going to enable clip descendants. Now inside of the frame, I'm going to create a local script, and I'm going to delete this print, and the first thing I want to do is get a reference to the frame. So I'm going to create a variable called frame and get the script parent, which is the frame. The next thing I want to do is get a reference to the camera. So I'm going to say camera equals workspace.currentCamera. I'm now going to get a reference to the viewport frame. I'm then going to loop every descendant of the map folder, and if the descendant is not a base part, I'm going to continue, which means to skip this loop. But if the descendant is a base part, I'm going to clone the descendant and then parent the clone into the viewport frame. If we now test the game and go into players and go into my player and player GUI, screen GUI, frame, viewport frame, we should see that everything that was inside of the map folder has been cloned into the viewport frame. Now let's create a camera for the viewport frame. So I'm going to say viewport camera equals instance new camera, and I'm going to set the field of view to 20, and I'm going to set the viewport frame's current camera to the viewport camera. You may be wondering why I decreased the camera's field of view down to 20, and the best way for me to explain this is if we watch this video, and we can see that as the field of view increases, the image gets distorted and morphed. So when we update the viewport camera so that the transition is not jarring, we use a low field of view to keep the minimap as flat as possible. Now let's update the viewport's camera but without any optimizations. So the first thing I'm going to do is create a vector free called offset with a y-axis of 500. I'm then going to use the camera to detect when the focus position has changed. I'm then going to get the X and Z position of the focus position. I'm going to use the X and Z position to create a vector free called position, and then I'm going to use the lookAt constructor to create a C frame for the viewport camera to look directly downwards to the floor at the position. If we test the game now, we can see that the viewport camera is being positioned and updates whenever I walk around. And if we go to my player's GUI and we select the frame and turn off clip descendants, we can see that unlike at the start of the video where the viewport frame was optimized so it does not have to constantly render, we're currently always rendering a new viewport image every time the camera focus point changes, which is not the most efficient method. If we go to the viewport frame article and scroll all the way down to performance, we should see that it says the viewport will only update when its children, camera or objects within are changed. We can also see that it says a viewport frame is not designed to render a large number of complex objects. It may be slow if you put too many objects inside. So what that means is, as long as we don't move the camera or move any of the clone parts, the viewport frame should not need to render a new image. So in order to optimize, what I'm going to do is change the camera's X and Z position into chunk positions. So the first thing I'm going to need is a variable called chunk size, and I'm going to set this size to 128. I'm now going to divide the camera's X and Z position by the chunk size. And for now, I'm going to comment out these two lines here, and I'm going to simply print the X and Z position. So if we ignore the minimap and look at the output, we can see that we're currently at a position of 0.0, and as I keep walking forward, this increases, and once I get to a distance of 128, it should go into a value of -1. Now I'm going to round down the X and Z position to get the chunk. And if I now print the chunk position, we can currently see that I'm at a chunk position of 0, -1. And if I walk a total of 128 studs, -1 should turn into -2. Here we can see -2. And to work out whereabouts we are within the chunk, what I'm going to do is use the modulus operator and wrap the camera's X and Z position around the value of 1. So if I print the X and Z values like this, so if we now look at our Z position of this chunk, we're at 0.9, and as I walk, it will decrease down to 0. And once we get to 0, it should wrap back round to 1. So here it's 0, 0.0, and here it's 0.9. If you're not too sure how the modulus operator works, you can check out my channel where I have a video called Modulus Operator, which will go into more detail on how this operator works. So now we know what chunk the player is on, and we know whereabouts within the chunk the player is at. So let's use this position to position the viewport frame. So I'm first going to delete this print, and I'm going to set the viewport frame's position 1 negative X and 1 negative Z. And the reason we did 1 negative is because when my character walks towards the right side, the minimap needs to move towards the left side, so it's the opposite side. So as you can see, as I walk right, the minimap shifts to the left, and once I get to the end of the chunk, it wraps round and moves back to the other side of the viewport frame. This can be easily seen if I go into GUI and set clip descendants to false. Now we can see it moves, and once it gets to the end, it should wrap round back like so. Now let's make it so that whenever we enter a new chunk, we update the viewport camera. To do this, I'm first going to store the current X and Z chunk position. So I'm going to create two new variables, one called chunk current X and current Z, and by default I'm going to set them to math huge so that it updates instantly as soon as the script starts. I'm now going to check to see if current X or current Z is different from chunk X or chunk Z. So to do this, I'm going to say if current X is not equal to chunk X, or current Z is not equal to chunk Z, then I'm going to update the current X and Z to the new X and Z. Now I'm going to move this commented code back into this area here and uncomment them. But I'm going to change the position, so instead of using the camera's X and Z, what I'm going to do is use the chunk X multiplied by the chunk size. And the same for this one over here, but instead of X we use Z, like so. We also need to shift this position by 50% of the chunk size, because currently the camera is being positioned at the edge of the chunk, but we want the camera to be at the center of the chunk. So at the top here, I'm going to create a new variable called chunk half size, and it's going to be half of the chunk size. And now I'm simply going to add the half chunk size to both the X and the Z, like so. And now we should see that the minimap works a little better, but when we walk off the edge, the image does not align correctly. If I change the offset from 500 to 725, now when I change from one chunk to the other chunk, we should see that they align correctly and there's no jump. But if I change the chunk size from 128 to, let's say, 100, now we can see that when the viewport frame wraps, it doesn't align correctly and there's a jump. So the relationship between the chunk size and the offset is very important, that we calculate it correctly so that the chunks align correctly. If we look at this diagram and we imagine that this purple cube is the camera and the distance from this black line is the offset and this black line is the chunk size, we can see that if the offset is too large, then the field of view will go off the edge of the chunk size, and if the offset is too small, then the field of view will be too small to fit the entire chunk into the image. But if we calculate the offset perfectly, then the field of view should match perfectly with the chunk size. And this is the formula that we can use to calculate the offset using the chunk size, or we can calculate the chunk size using the offset. So we can use the offset to calculate the chunk size, or we can use the chunk size to calculate the offset, but I want to use the offset to calculate the chunk size. So I'm first going to move the offset to the top, and I'm going to set the offset to 500. And instead of setting the chunk size to 100, we're now going to use the formula that I showed in the diagram to calculate the chunk size. If we test the game now, we should see that the Minimap is doing something strange, where it's kind of aligning correctly, because we can see it's perfectly aligned at the corners, and if I turn clip descendants off, we can see that this is the chunk and it's perfectly on the Minimap. If I move over here, we're now showing perfectly the other chunk. Now the reason this is happening is because our viewport is double the size of the frame. So if I come into the viewport frame and change this 2 to a 1, we can now kind of see that it's working a lot better. So as I walk up here, this corner is shown and then this corner is shown, like so. So our problem is that our viewport size is double the size of the Minimap. So to fix this, all we need to do is divide the chunk size by 2, like so. And now, when I walk from chunk to chunk, we can no longer see the viewport updating. And if I look inside of my player GUI and set clip descendants to false, we can see the viewport updating and the transition being smooth. We can slightly optimize this formula because we're multiplying by 2 and dividing by 2, so they cancel each other out. So we could simply delete both the multiply and divide by 2, and this should give the exact same result. Let's now add the ability to zoom in and out. So I've added 2 buttons, one called down button and one called up button, and I have created 2 functions that are connected to the activated event for both of these buttons. So when the up button is activated, what I'm going to do is update the offset, and I'm going to add 50 to the y-axis. And now I'm going to make sure to update the chunk size the same way we did before, and also make sure to update the chunk half size. Now that we've updated our offset and chunk size and half chunk size, we're going to need to do all this. But instead of having to write it all again, what I'm going to do is create a function called update, and I'm going to move all this code into the update function. And now inside of the focus changed event, I'm going to call the update function, and I'm going to do the same here and call the update function. Now when we call this update function, because the camera has not moved, the current X and chunk X will always be the same, so it would never be able to get into this part of the update function. So in order to force it to pass this check, what I'm going to do is copy this and change the current X and Z to huge again, so that when we do call the update function, it always goes into this part of the update function. And now I'm going to copy and paste the up button into the down button, and I'm going to change this from positive 50 to negative 50. And now I can use the up button to zoom out and the down button to zoom in. Now let's add player indicators. So I've added a white dot image label with anchor point set to 0.5, 0.5, and the position set to 0.5, 0.5, and the size being 6 by 6. Inside of the image label, I have placed a text label, and the text label has an anchor point of 0.5 by 1, and a position of 0.5 and negative 2, and a size of 60 by 14. Now before I continue, I'm going to slightly clean up the code so it feels more organized. The first thing I want to do is create a function for setting the offset. So let's create a new function. And I'm going to create these variables, but to equal nil at the very start, like so. I am then going to move this into the function and get rid of the local and change the 500 to equal the value, and remove some of these empty lines, like so. I'm also going to make sure to update when we set the offset, and I'm going to set the offset to 500 at the very start. And now inside of our buttons, instead of calling this, what we can do, we can call set offset and paste this into here, like so, and then delete all this, and do the same for the down button but with negative 50. And another change I'm going to make is, instead of this event calling a function that calls another function, I'm just going to call the function directly. So I'm just going to say update, like so. And finally, I'm going to move these variables to the top, like so. Okay, so now that we've organized our code, now let's add the player indicators. The first thing I'm going to do is get a reference to this image label and set the parent to nil. So I'm going to store it in a variable called player GUI, and I'm going to set the parent to nil. the next thing I want to add is a table called players, and it's just going to be an empty table for now. I'm now going to create two new functions, one called player added and one called player removing. And I'm now going to connect the two functions to the player added event and the player removing event. Now, because a player can enter the game while their players already playing the game, it's important that we scan for players before we connect the player added event. So I'm going to loop through every player that's already inside the game and call the player added function. Now, when a player is added, I'm going to clone the player GUI. So first, I'm going to create a variable called GUI and clone the player GUI, and I'm going to set the text labels text to the player's name, and I'm going to set the parent to the frame, and I'm going to add this GUI to the players table that we created up here. And when a player is removed, we're going to destroy the GUI and remove them from the table. And I'm now going to create another function, and this function is going to be called update players. Now, we can't update the players when the focus changes, because if you stand still and other players move around, their position will not update. So we must use the run service to update the player's position. So I'm going to first get the run service, and now I'm going to connect the update players to the render step. So over here, I'm going to create a connection to the update players function on the render step. Now, for the update players function to work, we're going to need the camera's focus position. But I think I want to rename these variables to something more meaningful. So I'm going to change it to focus X and focus Z. Like so. And now I'm going to copy and paste these two variables over to the update players function. And now I want to loop every GUI inside of the players table. And inside of this loop, the first thing I'm going to check is to make sure that the player has a character. And if it doesn't, I'm going to continue, which means to skip this player. The next thing I'm going to do is get the character's C frame using the getPivot function. And then I'm going to use this C frame to get the X and Z position, which I've divided by the chunk size. And finally, I'm going to position the GUI using this X and Z position. And now we should be able to see other players on our minimap and also our own character on our minimap. Now, currently, we're placing all the clones into the viewport frame as soon as the script starts. While this is fine for the few amount of parts that we have in our game, if your game has thousands of parts, it might be better for you to organize your clones into chunks, and when we update the minimap here, to add only the parts that are within this chunk. So that would reduce the amount of parts you have inside of your viewport frame. Thank you for watching my video, and if you have any questions, feel free to leave a comment down below.